I'm coming from the Technical University of Valencia, from the Biomedical Medical Informatics group. In that group, together with Alberto Maldonado, this is here too, we started working with all this stuff about archetypes and, well, from the very, very beginning. I think the first things we did was in 2002. So if you remember the dates told by Thomas before, we were really since the beginning. And as a research group, we wanted to focus on something a bit different. The question for us was not about how to create those future-proof systems based on archetypes. For us, we saw the methodology and we thought, okay, we think this will succeed. We think there will be systems based on all this technological stack about using archetypes and using the dual model. So what can be our target research? Well, we thought there will be those systems somewhere in the future. We have we have seen today 12 years, but well, they have arrived. But then we thought, well, there will always exist systems that will not work with archetypes, systems that work with other things that are, we call them legacy systems, but are not necessarily legacy, but just they do not use archetypes. So we wanted to focus on how to move data from these kind of systems into archetype-based systems. In fact, the problem in general is the problem of transformations. The transformation of data and transformation of models, we will see, is one of the key elements for data communication and reuse, because like or not, we will always have different, as I say, different systems, different standards if you want. Hopefully we will get to 5 different or 4 different standards, but there will be different. So there will be always the need to transform from one piece of data to another. And well, so the work done is still valid, and I'm sure that will continue to be still valid. So obviously this has a bit evolved. Now we talk a bit more about the reuse of data. That is the way how can we move data from the original input formats, or the register format when they introduce it in the clinical systems, and how can we start working with that data, extracting them, and bringing it to another kind of uses. We will see here in this conference about decision support, but we can talk about, well, any kind of transformation or abstraction of that data. And as I said, always thinking that we can work with different standards, with different models. We can have a prescription system working with OpenAir and a health information system that generates a CDA document, and at the end we want to mix all that into ODM, that is a standard for clinical research, and we want it to put into a research database. So, well, this is the focus, the target we are seeking. When we talk of transformations, in fact, we can divide the problem into 2. One is what we could say the model transformations, or the clinical information model transformations. That is, at the end, those archetypes. Archetype is a type of clinical information model, but we can have those templates in the sense of HL7, or we can have the patterns we will have in CIMI, for example. Well, are semantic artifacts that are defining some kinds of information structures for clinical data. One thing we can do is, well, how can we transform those models so that we can reuse them, that knowledge that is expressed in those models, into other systems? That is one of the problems. And the second problem, as I said, is the data transformation. How can we transform the bits that are really stored, and can we put it into a different format? I will not enter very much in model transformations. I will just put this. That is basically the 2 things that are being worked. This is a bit behind, I think, it's still in research, in this research or development arena. Basically, we could think that 2 approaches. Okay, we have models from different standards, maybe we can create through ontology mapping, through model-driven engineering, some kind of transformation. So we can take, for example, an OpenAir archetype and transform it into a 13006 archetype or to a CDA template or whatever. That is one approach. The other approach is, we could say, a top-down, that is more or less the one that is taken by CIMI. That is, well, let's define first a very generic model. Let's define clinical patterns, clinical information models, and then we will see how from there we can generate the actual OpenAir archetypes or 13006 archetypes. So let's see. There are more or less the two approaches, and as I said, this is something that is in development. Okay, this will come, but we can work with data transformation, as I said. Which is the situation or the expected situation? Well, that we have seen those systems that are able to work with archetypes, with a standard or with a reference model, and those systems are generating data and are storing those data in those formats. So, if we want to exchange data between two of these systems that do not follow the same standard, the same reference model, what can we do? How can we make that data interoperable? This is just a problem of mapping. Mapping is an old, not technology, an old thing in the computer field. From always, we have been working with transformations of data, but we will see the things that are a bit different when we work with archetype-based systems. Basically, well, I should have adverted first that this will be a technical presentation. So this is more of interest for the technical people rather than the clinical ones, but I will try not to make it very complex. When we talk of mapping, at the end, the idea is very simple. We have some original or source data. As I say, I put in here legacy data, not necessarily that is old data, but not the standard data. And we have a target schema, a target information model, where we want to move that data. So when we talk of mapping, usually we talk that we have to define that, and this is usually done by hand. It's very difficult to create those kind of mappings completely automatically. But the idea is that we create those mappings, those bindings between the source schema and the target schema, and a tool or whatever is able to generate from that a program, a transformation script, something that is able to transform the instances of data from the origin to the target, from the source to the target. So this is the basic idea of any mapping tool. As I said, this is an old technology, and there are many tools that do these things. Sometimes they are scary when you see those transformations things. But well, as I said, it's just a question of saying, well, this data value, because we always should work at the most primitive data value, at the strings, the numbers we have, and we say, well, we take this value from here, we put there, and maybe we apply some kind of transformation function because we have to change from meters to centimeters or whatever. So far so good. That is, I called it here single level mapping. But now we are talking about archetype-based systems. An archetype at the end is a constraint. That means at the end that is when you are defining an archetype, I'm not talking from the clinical perspective, but from the technical one, what we are doing is to create a kind of sub-schema of the data, a schema that is more more constrained for a purpose, for a single use. So how can we work with this more specific schema, given that we also have the reference model that we still have to create the data based on that reference model? Well, we could try to move these archetypes towards this single level mapping I told before, by creating some kind of ad hoc schemas for using those tools I said before. But we prefer to go to the hard thing and say, no, if we have an archetype, why not map directly the archetype to the source schema, to the original schema, and keep working within the methodology. So that's what we started doing, as I say, 10 years ago. And the result was this tool, LinkEHR Studio. LinkEHR Studio is, in fact, two things. It's, on the one hand, it is an archetype editor that can work with any reference model. You can import a reference model and just create archetypes based on it. We have tested it with 1306, OpenR, CD8, Fire, EODM, and many others. And, well, that's one part, probably most interesting for the clinical people. But the second part of the tool is the mapping thing. In this case, this tool helps us to define those mappings I told before and to generate those transformation scripts. From this perspective, this mapping functionality is purely oriented for the developers of the systems. This is not for the clinicians that create the archetypes. So that's why I'm talking about a lot of technical stuff. And well, another thing is that the transformations we do work with the XML syntax. We transform XML documents into XML documents, and our transformation script or transformation language is XQuery. Okay, so which is the real problem we wanted to resolve? Say again, a legacy model, or source schema, target schema. In this case, the target schema, we can say that is a reference model. And we have here an archetype. An archetype, defines a kind of sub-schema or more constrained view of the target schema. Data, and this is important to say, is always an instance or follows the complete reference model, the complete target schema, but it must also be compliant with the archetypes. So there is a duality, better said, in this data. So the mapping we have to define must be done between the source schema and this archetype. We'll see that the archetype plus the reference model, because we have other things to put there. And the idea is that from there we can generate the same as before, a transformation script or something that is able to transform from this legacy data into the standard data that is compliant with the archetype, but is an instance of the reference model. For doing this, obviously, as I said, this was started as a research thing, and really it deserves that work because there were many problems to be solved when we tried to transform with this thing of the archetype in the middle. One first thing is that say we have to generate instances from the reference model, not only from the archetype. So I'm talking maybe 8-9 years ago, we already did those idea more or less that Thomas explained this morning about the flat archetype plus the properties of the reference model. Well, we had to do that because we have to show all the possible places where data goes in an OpenR, for example, instance. We called it a comprehensive archetype. We needed also a function library for defining transformations. In this case, was easier because we just used the XQuery functions that exist. When we are generating data, when we are transforming data from an original format to a different one, it's fundamental that the result is compliant, as I said, with the archetype. So during this transformation, the script that we are generating is also checking all the constraints, all the things that are set, that are defined in the archetype. So at the same time that we're transforming, we are assuring that you are not getting, for example, or if the archetype says that a value is mandatory, and you don't find it in the source data, you cannot generate an instance for that because you lack that value and it's mandatory in the archetype. So these kind of things are controlled by the transformation script. And finally, during all this process, there is also a part of integration of data, aggregation of data, because the idea is that at the end, an archetype is usually contains quite a very well-defined set of data values or data items, and probably in the source, those data are scattered somehow. So we also tried, if you need to fill all these fields from different parts, we try to accommodate, to aggregate somehow this data in order to generate a single instance of that. So these were the things that we solved, which is the best example to be shown, the blood pressure one. I will show it with the tool, but the ideas you will see is just that this is just what we could extract, for example, from a system. They just store a date, a value systolic and a value diastolic without. And through the archetype, somehow, with this mapping, so we are going to define, through the archetype, we can generate an instance that is compliant with the reference model. So I think. So this is the linker tool. I have to look there. Okay. As I said, I will just start with a very simple example, just to get the basic idea. And as I said, this is the typical blood pressure archetype. This is the opener, a simplified one, I think, but we have here the observation with systolic, diastolic, and the position. And this is just the editor part. I will not enter in this. But we have this archetype. As I said, our target is, okay, we have some original data and we want to move it, to transform it into this schema, into this format. The first thing to do, as I said, to generate what I have called the comprehensive archetype. We need to merge this archetype with all the other properties that are in the reference model. The reference model is not only what we see in the archetype. With all of the open-air reference model, there are many things that are hidden for the clinicians that are working with the archetype view. There are many properties, many context data that is there because when we store the data, we need to have all that secure, well-defined, well described. That's not seen by the clinicians, or it's not seen when we see the screens with the data, the beauty data, but it's behind. So when we work in the transformation field, we have to work with that. We cannot avoid it. So when we enter into the transformation view, the first thing that happens is that the archetype is completed with all the properties of the reference model. In this case, these are all the properties of the open-air reference model. As I say, it's a merge. So there are properties that were not at the archetype, but things that were at the archetype are still here. We can see the systolic, the diastolic, the position, accompanied with many other things. As I said, now the mapping, what is the idea? All these colors, these greens, means that there is a mapping defined there. So it doesn't mean that it will work, it will generate something useful, but it is that you have defined something. It's obviously a responsibility of the administrator or the editor of this to make that correct. Okay, just a simple one. For example, the systolic. At the end, we have to move to the real data value. I can show first this. For example, the units of the systolic. If you remember in the slide, it was just the tag systolic, diastolic, 90, and whatever. It didn't talk about the units. All that, for example, can be defined at the archetype. And when we move to the mapping, that is here. At the end, the units are in this string, and we can just define this constant value. Well, these are millimeters of mercury, and that's all. When we move to the value, in this case, it's a bit different. In this case, you can see that the mapping instructions, well, this is the original path, or the path for that data in the original format. It's found in somewhere that is called data, that is called patient, and the systolic field. And we can define this. Well, in fact, if I enter into this is the complete mapping thing. There are many functions you can apply to transform data, apply mathematical functions, transformations of strings, transformations of data and times, some ontological. This is, in fact, what access to the terminology part or the metadata of the archetype. We want to get the descriptions of the archetype, for example. Well, and there are also some things that we are working with SNOMED. Aggregation functions to do some counts, sums, or whatever. Constraint values. If you define, for example, a list of possible values, then the map must be one of these. In this case, they would be shown here, and you select sitting, for example, and you just use that value. And finally, the data source. I have not shown it, but well, you import the schema of the data source, and then you can access. This is what we have in the original data: the date, the systolic, diastolic, position, whatever. You just select one of these fields. You apply some functions. This is just a formula you define, and okay, you accept, and that's all. You have that mapping defined. And we have to do it with every single data we want to put there. Obviously, nowadays, the problem is that the archetypes or the reference model asks for many data that does not exist in the systems at all. But, well, let's hope that someday we can complete all of this. This is a simple mapping, and another example is, for example, the position. In the case of the original data, this is just for example purposes. But well, we said that we had these 4 positions coded as 0, 1, 2, or 3. Well, we can define some conditional tables like this, where we can say, well, if you find a 0, then what we want to get is the standing word, or it could be a code or whatever. If you find a 1, then you get a sitting. If you want the 2, declining. And finally, if you don't find anything, the assumed value is sitting. And work with those assumed values that also exist in the archetypes. So basically, that's all. That's to define a mapping. As I say, it's a technical work. One advantage is that it's usually defined only once. You define once mapping between the schema and the archetype, you compile it, and you execute it when you need. We will see it later. So once you have everything defined, this is put in green. In fact, one condition is that if you have a mandatory attribute in the archetype or in the reference model, you have to define. It's mandatory to define at least a mapping for it, because you have to put a value. It's mandatory, as I said. So until that's not accomplished, the root is not green, and when it's green, so you can go ahead. And in that case, we just have to compile. We compile the mapping. Push this button, and that's compiled. Well, this is some summary things that we had, but at the end, the result that has been generated is in this screen. Sorry. This is the result of the compilation. As I said, it's an X query, but it's a quite complex X query, even for this very simple example of the blood pressure. But as I said, nobody said that transformations were easy, and we have to check all those constraints. As I said, if we said that systolic and diastolic are mandatory, there is code there that checks that you get a value for that. So this is the result, and we can test it. It's in this window. Okay. We just test it. Well, I have. Okay. It's an ugly representation again, but well. What we have get here, I should have shown the original data, but well, was the one of the slide. It was just. And what we get is this thing that, well, the important thing for us as a technician is that it's an OpenR instance. In this case of an observation, but we have here all the properties, all the values of that instance. In fact, this example had 2 patients, one with this measure for blood pressure, but there was another one that had 2 different measurements of the blood pressure. So the system, this is the part of the aggregation I told before, is able to identify that this data is from the same patient, and we can put it all together at the correct level, obviously. We are not, in this case, generating, well, it could be 2 observations, I don't know. Probably this should be 2 observations, really. But well. Well, if it's a time series. Okay, well. So that is a basic example. I will show some others. I will go quicker with those. So where is the... Oh, this is for me. Thank you. No, doesn't work. Yeah, no. I don't think we have improved. Yes. Okay. I should go back to the presentation. So. Well, just to mention, well, this is what we have said. As I said, this tool, the one important thing is that it's based on the archetype approach. We work with the archetype model. We don't mind about the reference model. The reference model is something that is there that gives us the pieces we have to use, but we can work with any reference model. This, for example, an example we are working now. Importing this famous fire that everybody talks about it, so we also talk about it. We can create archetypes for fire, and we expect that we can generate also fire messages, for example, or we can generate CDA documents. That is the next example I will show you. For example, this same, in this case, this is a CDA document. This is a bit curious because 10 years ago, when we went to conferences, we were usually the only ones talking about archetypes. And the last conference I have attended, we are the only ones talking of CDA. So it's a bit curious. But well, we work with CDA and archetypes. CDA is quite more complex. I will go to the full view, to the comprehensive view. It has lots of things inside. It's an structured body, it has a component, it has sections. This is current problem. Many things. Mapping a CDA is a bit of a nightmare, but it can be done. At the end, the process is the same. We compile this thing, we generate this X query. In this case, you can see that it's a bit more complex. Are complex, but are really executed quite quickly. Usually in 100 milliseconds or something like that for a patient summary, for example.
Which is the biggest amount of
of different patient instances. Usually it's not a good approach that it's possible that you execute the query on all patients altogether, but it's usually to go one by one. And in that case, we have been working with data instances of half a megabyte of a raw XML, so that's quite a lot for generating some kind of patient summaries, for example, things like that. Well, when we try this thing, it's here. Well, in this case, the data, I don't know if I can see it. It's a kind of nightmare. Well, this is some clinical data, try to be as I said before, what you can get from a system just in XML. Some data about the patient, some data about a problem. Look here that we have two problems. One with a start date and another one with a start and an end date. And we will see that what are we able to do with this in the transformations. So now I don't know where is the window. Okay, we are going to transform this. And what we get, this is, if you know CDA, this is the standard XLST for CDA. And we can see that just defining transforming rules, you can divide, for example, the problems, the current ones with the past ones, because you can put a rule that says if the close date is null, then you put it there or you put it wherever. And handy as I said, well, we have a completely conformant clinical document, CDA. So, well, this is just to show that we work on the archetype level, not on the reference model. The tool works for any reference model. So, we'll advance a bit more. Now, the second case. What time I started? Okay. The second case, again, we have a source schema, we have a target schema, something more complex. What happens if both work with archetypes? Not necessarily that both work natively with archetypes, but we have an information model that can be archetyped. What does this mean? For example, we want to transform OpenAir into 1306 or 1306 into OpenAir. Those are two standards that work with archetypes. But for example, what happens if we want to work with CDA? We have seen that we can create CDA archetypes because, well, the CDA has a special way of creating their own templates that are not really computable things. But we can create archetypes that express all the constraints of a CDA template. And in that case, can we transform a CDA into an OpenAir, or can we transform an OpenAir into a CDA? Well, using these mappings, we can do it, because at the end, in this case, what we do is the same strategy as we have seen, but in this case, we will have an archetype for the source and for the target. And again, we will generate results, and that's all. In this case, the basic problem is that when we map an archetype as a source, and afterwards, when we want to execute that script, that transformation we generate, we are not going to the archetype path, because what we see is the archetype. We select an archetype path. But when we execute that over the data, we have to go to the data path. So we have to transform the archetype paths into instance path. And well, if we work with OpenAir or 1306, it's easy because we have an attribute called archetype node ID where we can use to filter things. When we work with CDA, it's a bit more complex. We have to do some tricks, but it works. I have 3 more demos, so just show them because they cover different things. A simple one again, the blood pressure, in this case from OpenR to 13.6, just to get the idea. And well, from OpenR to HL7 and HL7 to OpenR. In this example, we have defined the 13.6 archetype for blood pressure. And in this case, well, just to make it a bit more interesting, we have the systolic, the diastolic, the position, and, for example, the mean. And maybe you can also relate this to one of the first images I showed in the slides. That was, well, we can have systems that are archetyped or can be defined those data, and we want to start moving into the reuse of that data, generating other views for other things. Obviously, this is a very simple example, but it's the thing that maybe in the original systems, the mean is not ever stored, but it's something that we can calculate. And through transformations, we can start generating, if there are formulas, if there are logics for that, we can generate also additional data. So this is the case is the same. In this case, our source archetype, so, well, with the things that are direct things, for example, the values. In this case, you can see, well, the systolic value, you can get it from this archetype path. In fact, the archetype is here. We can see the blood pressure, the history, the events, data, and the elements with the things they have. But obviously, once again, maybe when we are transforming, we are generating data instances, it's not enough with the things that are said in the archetype. We also need to transform data that is in the context attributes. So we can show, in fact, the complete model once again, and we can get any information of the reference model, any data, and we can put anywhere. Okay. In this case, this is just we get this simple path. But for example, for the mean, well, we apply this well-known formula where we calculate 2 times the which is the diastolic plus the systolic divided by 3. Well, it's just an example that we can create those kind of functions. And again, well, the result is that we compile this, we generate an X query. I will not show it. And in this case, we are going to apply this to this OpenR observation, that is OpenR data. Okay. So we apply it. And the result is, well, in this case, a 13.6 that has some values and has this thing that has been calculated, and we have a 13.6 entry in this case. This is a simple example. Another one, that in fact, I think was the title that Luis put to the conference, to the talk. It's about, well, we can transform, for example, from OpenR systems to CDA and generate a kind of a document. In this case, I'm going to map this CDA to this problem archetype that, in fact, this is worth to mention. We work with archetypes, and for us, from always, the template concept has been always a constrained archetype. So we are happy to see that in the IDL 1.5, finally, templates are also archetypes, because this is what exactly we always do. If you want to map this composition. This composition has already solved the observation inside with the problems. So we work with that schema of data. So this is the, now I will go quick. It's exactly the same process. We map everything, and we get this transformation. We work with CDI, as I said, is okay. In this case, well, it's a very simple example, but we get, I have not shown the instance in detail, but we get the problems we had from OpenAir to this CDA. And the other way around, well, I will just show it, but it's more of the same. In this case, it's a CDA to OpenAir. Well, I think it only has one value. I had to do this last week, so it was quite. Okay, again, the mapping and the generated text query. In this case, this is a CDA document. I don't open it. This is a CDA document, and well, we get this OpenAir thing document, well, composition in this case. So this is basically what the tool does. As I said, it seems that it's easy, but it's not easy at all. When you talk of these transformations and you have the archetypes in the middle and you have to take into account many different things. One of the values that is given by this approach, as I said, is that we work with the archetypes in a native way. I mean, we have the archetypes. If we change the archetype because it evolves, you have a new version, we just have to redefine the mappings, we compile it, and that's all. The tool takes into account those changes. It will say you where you need to put a new mapping, for example, or those kind of things. That is the great advantage of working in this way, because you are really touching the archetype things. You are not moving to other technologies that, as I said, you can do mappings with other tools, but we are working with the pure archetypes. Just to finish, where can we use it? As I said, this tool is oriented for the developers of the systems. The results of the idea is that, well, they get the archetypes. The archetypes have been defined by somebody. The developers, or those who knows about the databases in the system or the formats in the systems, do the mappings, compile it, and the result is just an X query in this case. The idea is that you can put it anywhere in your system. It's a completely standard X query. You can put it at any place in your system where you have the need to communicate, for example, data. If you had to generate a CDA for sending it to EPSOS, well, you put the transformation at that point, and you generate the EPSOS CDA. Or if you want to, whatever. It's about executing that X query in the point where the business logic requires it. This is I remember about this because the example of Ian. This is a thing we did back in 2009, 2008, in fact. That was about that medication reconciliation problem that Ian explained. Was exactly the same. We have medication information in primary care, in the hospital. In this case, it was oriented for the clinicians that wanted to have all that information all together. And the idea was, well, let's define first the archetypes about the medication, so we can agree on the components of that, the data structure of that information. Then we map it. In this case, what we did is, well, we map this archetype in the primary care system, to the primary care system database, and we map it to the hospital database. The result is that we get the same kind of instances. There are instances of the same archetype, and in this case was 13606. So we can merge or combine them into a single view, like this, where you can see, well, here's the origin, this is the hospital system, and this is the primary care system. And then the doctors could decide if the medication is the same or not, or there was some incompatibilities. Well, there were other things, because there were some SNOMED mappings also to coordinate the terminologies and so on. But, well, this is 13606, in fact, behind this screen. And this proves that we use archetype as the common reference concept or information structure, and we can map it to different sources and then combine all that data, since it is in the same format. Another use case was, for example, using CDA archetypes for, well, generating data, CDAs for chronic disease information. And again, well, it's something that is possible to be done at the archetype level. This is a CDA archetype that we generated. And this is another example, another proof, well, another project we did, that was how to transform data from a commercial information system. I cannot say the company, sorry, because we had an agreement, a non-disclosure agreement. But the idea was, well, to transform data from a very important commercial information system into a contract research organization, that are those organizations that make some research for clinical research. And they used ODM. ODM is another standard that is in use in this research arena. So we did these transformations. The good thing of ODM, the ODM archetype is that one, is that they said it's based on CDA, but, well, it's not really nothing to do with CDA, in fact, but it really gets the same concepts as in OpenAir, as in 13606, as in CDA. It is an ODM is a kind of document that contains groups of data elements. So it's more or less a composition with clusters and elements. So it's perfect for creating archetypes. So we can create these archetypes and we can generate, this is ODM data. This is my last slide, I think. At the end, all this is about, we have reference model, we have standards. As I said, probably we will never get single one standard or reference model all over the world in all systems. That is completely impossible, I think. If we can get 4 or 5, we will be lucky, I think. And then we will need those transformations, or even we will always have old systems that we have to get data from them. So the idea is, well, put the archetypes, these reference models, and plus the archetypes, the dual model methodology, in the center of all the logics of the new systems. Because at the end, when you have an archetype that has a very good and formal representation of an information structure, you can use it to guide transformations. That's what I have shown you. You can use it to define, or together with a reference model, to define the data repositories that the previous presentations we have seen. You can use it to guide the queries that we also have seen. And all is based on the same archetype, on the same model, on the same definitions. And that creates that all the environment at the end is more powerful, is I think, more secure, because at the end you are working with a common reference. And, well, that's all. Thank you for your attention.